Welcome back to Zalot Studio channel. Zalot Studio channel is focused on conceptual and simulation virtual physics lab. So today's video lab lesson is capacitors in series. The capacitors connected in series combination, or capacitors that connected in series. So when a DC voltage V, that is the cell that supplied a voltage V, is in series combination of the three capacitors as shown below. So all capacitors experiences the same charges. All capacitors that stored the same charges. All capacitors, that is C1, C2 and C series, that stored the same charge Q in series. In series, all capacitors that experience the same charges, which is Q1 equivalent with Q, and Q2 that equivalent with Q, and Q3 that equivalent with Q. So capacitor 1 and capacitor 2, capacitor 3 are stored the same charges. Here it is the equivalent charge. The equivalent charge is Q. And here it is the equivalent capacitances. The equivalent capacitance or capacitor. So when voltage in all capacitors add up to the applied voltage of V, the applied voltage of V is equivalent with the voltage in C1 plus the voltage at supplied in C2 and the voltage that's supplied in V3. So V1 plus V2 plus V3, that is equivalent with what? V. Here the V is equals to V1 plus V2 plus V3. V1 mean what? The voltage that's supplied in V1, C1, capacitor 1. V2 mean the voltage that's supplied in capacitor 2, and V3 mean the voltage supplied in capacitor 3. Using the definition of voltage or potential difference is equals to, that is charge over capacitance. Charge over capacitance. Rearrange the above equation here. V total is equals to the sum of that add up of the applied voltage V, which is V total is equals to V1 plus V2 plus V3. Welcome. V mean the definition of V is equals to Q over C. Here V total mean Q over C total. Q total is Q here, and C total is also C total. That's capacitance total. So V is equals to Q over C total. That is equal with V1 mean Q over C1 plus V2 mean Q over C2 and V3 mean Q over C3, where C total is the equivalent capacitance of the circuit, the equivalent one. Therefore, here Q and here Q are the same, are similar, which mean take it in common, are constant, which Q. So 1 over C1 plus 1 over C2 plus 1 over C3 times Q, and Q cancel by Q both sides, and cancelling out of Q at both sides, we obtain what? 1 over C total, or 1 over the inverse of the equivalent capacitance, that equal with the inverse of C1 plus the inverse of C2 plus the inverse of C3. Welcome back to the simulation. Here is the total capacitance that stored 3 times 10 to the power of minus 13 Faraday. Okay, and the ability of pushing of the current, that is the potential of the batteries of the cell, that is the DC cell, that is 1.5 volt. So the charge that stored in this capacitance is 4.5 times 10 to the power of minus 13 coulomb, and the total capacitance of a capacitor is 3 times 10 to the power of minus 3 faradays. Let increasing the capacitor 1 into 2, okay, which is in series here, 2 in series, okay, the two capacitor in series. This is the total capacitance, and the stored here, total stored charge stored in capacitor, and here the total capacitance into the capacitor, the ability of the capacitor. Okay, here the field, okay, the electric field of line when it will on. Okay, welcome. Here in series circuit, the Q is the same, the charge is the same, and what the total or the equivalent capacitance, that is 1 over C total, is equals to 1 over C1 plus 1 over C2. So let the total capacitance is 0.5 times 10 to the power of minus 13 Faraday, and the individual capacitance, the capacitance of a capacitor is 1 times 10 to the power of minus 13 Faraday and 1 times 10 to the power of minus Faraday. So the total capacitor is 0.5. 1 over 0.5 is equals to 1 over 1 plus 1 over 1. 1 over 1 means 1. 1 plus 1 is 2. 1 over 0.5 is 2. 2 is equals to 2. See, okay. Let me increasing the capacitor in 3 capacitor. Here I have the same with here. Okay, and 3 capacitors that connected in series, the total capacitance is here given 0.33 times 10 to the power of minus 13 Faraday, or 3.3 picofarads, and each of capacitance have assume the same capacitance, that is 1 times 10 to the power of, or 0.1 picofarad, 0.1 picofarad, 0.1 picofarad, and the total charge in a series have the same, which is Q. So the stored charge is 0.5 or 5 pico coulomb, 5 pico coulomb, 5 pico coulomb, and 5 pico coulombs. So the total voltage is in each V total is equals to V1 plus V2 plus V3. V1 plus V2 plus V3. So V1 mean Q1 over C1. V2 mean Q2 over C2. V3 mean Q3 over C3. So the total voltage, that is 1.5. Therefore, Q1 mean 0.5 times 10 to the power of minus 13 coulombs, and C1 mean 1 times 10 to the power of minus 5 Faradays. So this cancel by here. 0.5 over 1 is 0.5 voltage. Coulomb over Faraday is voltage. So 0.5 voltage, 0.5 voltage, 0.5 voltage. Here the equivalent one is 0.5 times plus 0.5, that is 1. 1 plus 0.5, that is 1.5. So here have the same charge, and the sum of that the supplied voltage is equal with the total voltage, that is V total is equals to V1 plus V2 plus V3, and the equivalent capacitance is the inverse of the equivalent capacitance is equals to the individuals, the inverse of the individuals, that is 1 over C1 plus 1 over C2 plus 1 over C3. 1 over C1 plus 1 over C2 plus 1 over C3. 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C1 plus Okay, students, thank you. Any questions, please comment out. Thank you. Goodbye.